Good afternoon, everyone. I think it's time we get started with our webinar today, 3 Easy Ways to Run Containers on Azure. I'm Blaze Stewart. I'm architect at WinElect, and I'm a Microsoft Azure MVTP, Microsoft certified trainer, and a Microsoft certified expert on cloud and what have you. And today I'm going to be giving this webinar to kind of get you started or maybe increase your knowledge about how you can run containers on Azure. And we're going to be talking about just the easy ways today. There's actually a lot more than 3 ways to run containers on Azure, but these are 3 of probably the most common ways, and we will get into the details of these in just a moment. So let's go ahead and start talking about containers on Azure. So a brief introduction to what a container is, but just a few housekeeping rules here. If you have a question, there is a question box on the left over here that you can use to pose your questions. If you have questions, please submit those in the question panel there, and we will answer those questions at the end. We will have a brief period of Q&A at the end, in which I'll go through the questions and try and answer those for you. This webinar will be recorded, and we will put it on our YouTube channel, which is youtube.com/wintelectnow, and you can watch this at a future date once we have it recorded and uploaded, and we will have it available there for your review once we have that online. So let's go ahead and launch into containers and talk about everything related to containers on Azure. So just a brief introduction to what a container is. If you've never been exposed to the idea of a container, they're really easy to understand in reference to virtual machines, which people have a pretty good idea of what a virtual machine is. A virtual machine is essentially a machine that runs other virtualized machines. So you have a host operating system, and with containers, you have very similar stacks. So you have a host operating system for running containers as well. So on a virtual machine, you have a hypervisor, which is responsible for providing the abstraction to the virtual machines that run on top of a physical machine that is providing the virtualization. And similar in the container space, you have something that's called a container engine or container environment that is used to run containers. So these are very similar in these respects, but they differ in the next layer, which is where the virtual machine and the container diverge. Now, a virtual machine has a guest operating system that is used to run the libraries and bins and applications on top of that, while a container does not have a guest operating system. So essentially what you get with a virtual machine is a hardware abstraction layer that is exposed to the guest operating system in a way that allows it to run applications on that host as if it was running on physical hardware. So it virtualizes things like drives, network cards, RAM and CPU and so on. With containers, rather than provide hardware abstraction, it provides kernel abstraction. So you get a kernel layer that essentially gets exposed into the container that will allow you to run a application inside the container. So think of it as a virtual kernel, if you will. And then with virtual machines, you have libraries and apps, and on containers, you have libraries and apps. And the container would be this box here on the left right here, where you have a libraries and bins, and that anything that's encapsulated in these red circles I'm drawing would be a container, while a virtual machine would be more like what's running here. But you eliminate the need for the guest operating system right here in a container, so you have a lighter weight delivery of your application. The trade-off, though, is you make your containers platform specific. So Linux containers have to run on a Linux host, and a Windows container has to run on a Windows host. With a virtual machine, a Linux host can run a Windows container. Linux host can run a Windows virtual machine, and vice versa. So let's talk about the workflow, because this is important to understand container workflows as well when we start talking about some of these other options. So basically, a container workflow looks like this, where I have a local or dev environment, and I have a Docker file. And a Docker file, if you're not familiar with that, is a script that basically is used to build a container image from. And you call a command, say Docker build, and that turns that Docker file into a Docker image. And the container image is hosted on your local environment at this point when you do the build. So it takes all the instructions in that Docker file, and then it creates a package that has all of the software that you need installed in that image. And then you call something else like Docker push. And then that takes that container image and copies it up to a container registry. And once you have that container registry copied up there, that container image copied up to the container registry, you can then call another command, and that's the run command, whichever it might be for whatever environment you're running. And then with that run command, the container runtime will then take a copy of that image down to its local context, and then it will then take that image and run it as an actual container. So this basic workflow going from a build to a container registry down to a container runtime is the pattern that pretty much everything in the container space follows. Now your build environments might look different, the container registry might look different, the container runtime might look different, but those are the three critical components. We're primarily going to be focused on these three down here, the container runtime today, when we talk about Kubernetes, Azure App Services, and we're talking about Azure Container Instances on Azure. So to show my cards here about what we're going to be talking about as it relates to the three easy ways to run containers on Azure, we're going to be looking at these three ways, these three different container runtimes on Azure that will enable you to run containers rather easily. First, you have Azure Container Instances, which is used for single instances. And this is a very, I would say, basic way to run containers on Azure. It's very easy to use, and it spins up quickly, and it's billed by the second. So it's really designed for kind of that entry level into containers. And we'll look at this in just a minute in more details. Then scaling up one level, you have Azure Web Apps for containers. Now what this is the ability to run Docker containers inside of Azure App Services. And Azure App Services is the platform as a service offering from Azure for pretty much running all kinds of applications that are, generally speaking, oriented towards web apps. And these applications would be running on an environment that would be exposed through HTTP or HTTPS, and that would be very similar to what we do with what we were running on Docker containers for serving up some kind of application that is going to be running typically a web app in a browser context, and that's what we're going to be using for our demos. And the scale for web apps for containers is usually between one and a couple dozen containers running in app services. But when you get beyond that scale is whenever you get to something like Kubernetes. And Kubernetes is a full-blown container orchestration stack on Azure, but it's provided as a service, and we'll dig into the details of this in a moment too. So those are the three things we're going to be talking about today, and that's kind of the order of scale which we would want to talk about them as well. So let's talk about Azure Container Instances, and this is just a very easy to use container offering on Azure. Azure Container Instances gives you the ability to deploy a container straight to the Azure without spinning up any platform. So basically, you can just go right into the Azure portal. You can go through a wizard and then come back in about 5 minutes and you have a container running. And it's running with a public IP address with ports exposed. You don't have to really do any kind of the provisioning of any kind of infrastructure to make that work. So once this is up and running, you can use it and shut it down rather quickly. And these things boot up quickly, they shut down quickly, and they're really designed for those small scale workloads on Azure. The container instances can integrate with a number of other things like VNets and file storage. We're not going to get into these details today, but they can integrate with this so that if you have something running on your virtual networks on Azure, or you want to persist things outside of a container, which is good practice, you can use Azure File Storage and Azure VNets to accomplish a lot of that. So Azure VNets would be useful for running things like hybrid approaches to cloud, or maybe integrating Azure Container Instances with virtual machines running on VNets and things like that. So there's a lot of flexibility with container instances when it comes to integration with other Azure services. Now, there are some limitations, as we'll talk about those in just a second, but this is the general architecture where you have a container, a primary container, and it gets deployed into container instances, something called a container group. And then you might have a container that's called a sidecar container running inside of that. Now, one canonical example in this is typically for small apps. If you only have a single instance of that and you don't really need HAA for that, high availability for that, you could have the primary container be something like a web server and the sidecar container be something like a database running in that container. Or maybe your primary container is a web server and the sidecar container is something that's monitoring it. So a container group is deployed to a container instance on Azure, and they contain you can have multiple containers within a container group, but generally speaking, you only have one on Azure Container Container Instances. It's basically the deployment, the minimum deployment option for Azure Container Instances. So technically, yes, you can run multiple containers on Azure Container Instances, but they always come as a group as defined by a container group on Container Instances. And then with these, you can connect an Azure VNet, file storage, Key Vault, and other services related to those. There are some limitations of these. The Azure Container Instances has very little by way of scaling. So you can't say, hey, I want 10 container groups running. You would actually have to create 10 container instances to get any kind of scaling out of that. Out of the box, there's no automatic scaling with container instances. So if you wanted to use this for scaling, you would have to custom roll something. And generally speaking, if you're going to do that, you might as well go to something else like app services or Kubernetes. Secondly, other network integration like load balancers and gateways must be configured separately. Now, with app services and Kubernetes, out of the box, you get you get to deploy these rather easily. Just by turning on as something in Azure App Services or configuring Azure Kubernetes Services to do HTTPS ingress or something like that, it will automatically provision load balancers and app gateways for you, while this will not do that. So those are some limitations to this. And generally, the load balancers and app gateways are going to be related to scaling anyway for load balancing purposes. So if you need something beyond a single instance of a container, think about some of the other options that we're going to be talking about today. So I'm going to do a brief demo of this. Now, in my demo here, I'm going to do basically look at a little file here, a little demo here that I have that is going to deploy a container to Azure at Container Instances. So I have it here in this. I have a Docker file that we mentioned, and this Docker file builds a container that will run a game. It's going to run Commander Keen. If you've never played that, it's a really old DOS game, and it's one of my favorite ones from when I was a kid. And so I figured I would write a container that would actually run that DOS game in a browser. And so to build this, I was playing around with this, and if I wanted to build this, I simply call docker build. I'm in the folder right here, so I'm going to call docker build, and I can do a -t, and I'm going to tag this Blaze Keen, and I'm going to say use the Docker file in this folder. I need to get into the folder that contains the Docker file, though. Since I'm not in the folder that contains the Docker file, let's call that command again. And since I've already built this, it's just running it from cache. And then once I have this, I'm going to do a push to Docker Hub. So if I do push, I'm going to do blaze/keen, and this is actually going to push it up to the container registry. And since I've already pushed this, it should push rather quickly. The layer already exists. Since I built it, the hashes didn't change. So it pushed this to the container registry on Docker Hub. So it's available for use already. So with this container, what I can do with it is actually run it locally. So I can show you what I'm doing here. If I do docker ps, let's do docker run -p, and I'm going to do a port, let's do 8081, and I'm going to do port 80, and I'm going to do blaze/keen, and this will start my container on port 8081. Now, if I pull up a browser here, and I go over here to my IP address for my virtual machine that I have running, I have a Linux virtual machine that's actually running this container, 128.255.128. 128, and then go to port 8081, I should be able to pull up this container, and this is using a VNC client that's running in a browser, and this will allow me to run my DOS game. So if I go cd, and then I think if I just run the installer for this, I can install.exe, and I can install this game really quickly and then start it, and this will start the game in a local context. So this is the container I'm going to be using for all my demos today. So it will allow me to run a game inside of a browser, and so you can see here that it's loading my game. And so once I have my game loaded in my browser, it's actually being served up in a local context now. So to make this run inside of a container instance, I'm going to go to the Azure portal, and I'm going to log in as me, and I'm going to go over here to create a resource, and I'm going to select containers here on the left, and I'm going to select container instances. Now, right out of the box with this, I can put this into a resource group. I'm going to call it Keen Demo, and I'm going to put it into the East US 2 region. Now, the image type I'm going to select here, I'm going to use a public image type, and I'm going to blaze/keen is the image name, and it's going to infer that I'm pointing to Docker because I didn't provide the host name for this. And I'm going to choose Linux for the OS type since this is a Linux container, and I can use this size, so 1 CPU and 1.5 gigs of RAM for this particular container instance. Now, this is enough to make this particular container run. Now, the networking side, I can include a public IP address, which I want to do, and I will want to expose a port 80, so that this will run in a public context. So this will expose this container on port 80. Since I have no SSL on this, I don't really need it. And I can give it a name if I wanted to. I can call it Blaze Keen, and that will actually create it at that URL if I wanted to. So with this, I can have restart policies on the container instance. I don't really need to set any of this. I can set some Azure tags for management of this resource and things like that. And once I have this all ready to go, I can go create, and I can come back in a little bit, and this container will be deployed, and we can actually see it running inside of a browser. So I'm going to let this deploy, but I'm going to go back to the deck, and we'll revisit this in just a moment whenever we get to our next demo, which will be our demo talking about Azure App Services. So keep this demo in the back of your head, and let's go back to the deck for a moment and talk about Azure App Services. So in the last demo, we looked at how to create a container using the Azure portal for Azure Container Instances. In this one, what I want to look at is creating Azure Web Apps for Containers and talk about what is that and how does it relate to App Services. Now, Azure App Service enables you to host in all kinds of things. Web Apps for Containers lets you run containers in Azure App Services, and Azure App Services can host web apps, mobile backends, and RESTful APIs. Basically anything you can serve it through a website. So that would be what Azure App Services is for, and Web Apps for Containers allows you to take your web-based application, package it as a container, and then run it on Azure App Services. And this allows you to basically run it in any language of your choice. So out of the box, App Services supports .NET, Node.js, PHP, Java, Python, and a myriad of other options. But if none of these are to your liking, you can bring your own. You can take your container and package your application inside of your container and run it on Azure App Services. So, for instance, if I wanted to run a Windows container that runs an old ASP, classic ASP app, I could do that in a Windows container and then put that on Azure App Services. Or if I was running a more esoteric programming language that isn't supported out of the box, that is used for web development, say maybe Ruby or something like that, that's not supported natively by App Services, I could build a custom container for that environment and deploy it as such as well. So there's a lot of flexibility by adding containers to App Services, and Web Apps for Containers is how you do that. So it also lets you choose the operating system. As I mentioned, you can run it under Linux and Windows. And remember, with applications running on App Services or any context in Linux in a container, that container is platform specific. So I need a Linux host to run Linux containers, and I need a Windows host to run Windows containers. The basic differentiator between Linux hosts and Windows hosts on App Services is some of the functionality in one is not available in the other, and vice versa. It would be beyond the scope of this webinar to get into the weeds on that, but know that you can run containers in both of these environments. But just remember that if you build a Windows container, it needs to go into the Windows app service, and Linux containers need to go in the Linux app services. And with app service plans, you end up with something like this, and this is how containers get reflected in that, where every app service plan can have multiple app services, and then the deployment slots basically become where your containers reside inside of an app service. So if you're familiar with app services, you have an app service needs at least one deployment slot, and then with a deployment slot, you can scale out multiple deployments into deployment slots, and each deployment slot would then have a container running inside of that. Now, it's in beta right now. There is the ability to run multiple containers in a deployment slot as well, similar to how you would do it inside of a container instance, where you have a primary and then sidecar containers in a deployment slot. Now, that's still in preview, so it's not GA'd yet, but the principle still here is that you can scale deployment slots, and by scaling deployment slots, you can scale your containers as well. And the app service itself, it will determine what scale you can use that at. So a standard, I think you can get up to 10 deployment slots. With a premium, you get like, I can't remember the number exactly. I think it's like 50, but that means you could run up to, maybe 50 instances of your container. If you're getting up to that scale though, where you're running, dozens beyond a dozen containers, app service is probably not the best thing for you. I would consider going to something like Kubernetes at that point. So with that in mind, let's go and look at Azure App Services. But before we do that, let's go ahead and check out our demo and see where we are in deployment of our container instance here. So going back to container instances, when I deployed this resource, I deployed it into my resource group here. So that's the endpoint for it, the fully qualified domain name. So if I go HTTP on that and I pull that up, it's going to give me a listing of my files on my web server. And just like we saw when we were running this in my local context, I'm now running this on Azure Container Instances. You can tell that by the URL up here. It's using azurecontainer.io, and now I'm running this container and an app and an instance here. So if I scale this up a little bit, maybe you can see it better. So if I go C:, and then I go CD keen, and then I run that installer again. Not installer, install. I'll run that same install. This game is now 30 years old, and it's still one of my favorite of all times. So with that in mind, I can run keen 1 and run this 30-year-old game on a Linux container running on Azure Container Instances in Azure, streaming back to my browser here over WebSockets, and I can still play this game just like it was back on my old 286 when I was 9 or 10 years old, way back when. So there we go, running a game on Azure Container Instances. So with that in mind, let's go over here to my resource group, and here I have already deployed an app service right here. If you wanted to deploy an app service inside of Azure, you would want to create a resource, and you could just do web apps for containers. For containers right here, and you would walk through this wizard. Because this takes for a while to deploy, I'm not going to do this, but basically the deployment is very similar to what we saw before, where you would come in here and you'd configure this for your image. So if I wanted to deploy Commander Keen like I just did into this, I would simply tell this to run Blaze Keen. I don't need to specify any startups. I'm using a single container here. This is that Docker Compose preview I was talking about that allows me to run multiple containers on a app service. I can compose multiple containers to run it in a single deployment slot on app services using Docker Compose there, but we're not going to get into that. With a single container, I can run just my Commander Keen container here, and I can turn on monitoring and so on. I've already gone through this to deploy this. So back inside of my resource group, I have my app service already deployed. There's my app service plan that contains my app service here. And my app service here then is already running. I already created this to be ready for this demo. And if I come down here to my settings, because I deployed this as an app, web apps for containers, I have this setting for container settings here. And this allows me to build out a Docker Compose if I wanted to change this to use Docker Compose for multiple containers in this, or I can do a single container deployment like I have here, and notice I already have it configured for Blaze Keen. And another cool thing about this is once you have it deployed, is you can pull the deployment logs for this to get an idea of what's going on inside of the container, or what's going on with a given, if you have issues with it and so on, with the container that's running in your environment. Now, all things else considered here with this app service, though, this is basically the same thing as a standard web app running in an app service on Azure. So the only major difference is that I can change it to a container here, but otherwise all the configuration stuff is here. I can have application settings that get exposed as environmental variables in the container. I can do path mappings. I can do I can set up storage to mount into this container. That the storage would come from my app service plans storage, or I can mount in the storage from Azure Files, just like I could with web apps and so on. And I can even put SSL in front of this and do load balancing if I have multiple containers running inside of this. If I wanted to scale this out to where I had multiple instances of it, I can scale it out here scale out right here. So if I wanted multiple instances of this container up to 10 with this standard, I could have 10 instances of my Commander Key container running. That would be kind of silly. But if it was a web app and I wanted a HA configuration with all of this, I could really configure this here or auto scale. Same story with this. I can set up probes against it to do all the same kind of things I can do inside of app services with a container here. And the beauty of all this, though, is I don't have to deploy any kind of infrastructure to do this. This is all managed infrastructure. It's a managed platform. So this is purely platform as a service for running containers on Azure at a scale that's somewhat larger than what you would get with a container instance. So let's go ahead and pull up this container and let's go see what this looks like. See if this will pull up right here. This one is running on HTTPS against this URL here because this SSL is working as a proxy in front of my container. I'm not actually using SSL in my container. The SSL is being brokered by app services, and so I get HTTPS with this one. Let's see if this will let me do the WebSockets through it, which is really what this is using to stream. And sure enough, it is. It's to let me run the WebSockets through SSL by proxying that back through my container, which is running on an unencrypted connection back to my container. So it's SSL offloading, and I'm able to play my game right here. Since I already ran this in the background, I didn't have to go through the installer. I actually ran this earlier today to set up the demo, and I'm just playing Commander King, having a blast doing this, reminiscing about how I used to run this on my old 286 here. So with that in mind, let's go back and do this in one more context, and let's talk about the Kubernetes for a minute. Now, we talked about Azure Container Instances for single instances. We talked about Azure App Services for larger scale instances. Let's go in and then let's flip back to the deck and then talk about Kubernetes, which is the full-blown orchestration stack that is the open source container orchestrator. So Azure Kubernetes Services is a service for running containers at scale on Azure that uses a container orchestrator that is designed to run containers literally from, as you can run up to a single container, which I'm going to demo here, but literally you can run thousands and thousands of containers on Kubernetes on Azure because it gives you the ability to scale Azure Kubernetes Services to literally hundreds of nodes that allows you to distribute your work across literally up to hundreds of virtual machines running on Azure. So what is Kubernetes anyway? It's designed as an orchestration engine for containers to both deploy, scale, and manage workloads, and it provides a lot of the infrastructure that you need to connect all that together. With app services and Azure Container Instances, a lot of those infrastructure components are just given to you, and you don't have a lot of configuration over those. With Kubernetes, on the other hand, you have the ability to massage it a lot more so that you can tailor it more specific to your application. Say you need an application to run on a port that's not 80 or port 443 on Kubernetes. Well, you couldn't do that with app services. You would have to do an Azure Container Instance to run a database. But if that and that database was, say, MySQL, that'd be port 3306. Well, I can't run that inside of app services and expose that to the public internet because app services won't let me do that. However, with Kubernetes, I can. And Azure Container Instances wouldn't let me create a cluster that would be HA because it doesn't support scaling of that. Well, with Kubernetes, I can. So you kind of get this best of both world approach where you have the ability to shape the environment to be what you need it to be with Kubernetes. And the great thing about Kubernetes is it's open source and it's owned by the Cloud Native Foundation. So no one company really owns Kubernetes. Rather, it's got a lot of buy-in from the community. And so cloud services like Azure, AWS, Google Compute have all provided some implementation of Kubernetes as a service. And we're talking about the Azure Kubernetes service that is provided to you from Microsoft. Now, what some of the advantages of Azure Kubernetes services is that you only pay for the nodes that you're actually using. So with a container cluster, you have master nodes and you have worker nodes. And worker nodes are the nodes that actually run, they're actually virtual machines that run your containers. And you only have to pay for the virtual machines that are actually running your containers on AKS. Now, if you were to build a cluster yourself, you would need those master nodes, and they don't actually run container workloads. They're responsible for managing the cluster, but you would still have to pay for those virtual machines. With AKS, you don't have to pay for those management nodes, only the container nodes, only for the virtual machines that are actually running your containers. It's a fully managed stack. And I put an asterisk next to that because someone brought it to my attention that, yeah, it's fully managed, but it's not fully managed in the respect of a platform as a service entity. There's a shared responsibility with AKS in terms of upgrading it. So basically, if you're running AKS and you select a version of Kubernetes to run, Microsoft is not going to update that for you. It's going to run on that version of Kubernetes until you go into the portal or through the Azure CLI or through PowerShell and upgrade that version. So it's not fully managed in that respect. Also, if Microsoft is going to apply the patches to the VMs, the operating system to Kubernetes, and do emergency patching, and in an emergency patch, they might reboot the nodes. But if they apply a patch to the OS and it's not an emergency patch or a patch to Kubernetes, they're not going to reboot the nodes for you. You have to reboot those nodes. And you can do that by scaling up, scaling down, or doing something like that, or upgrading the version of Kubernetes. And so there's a shared management responsibility. But generally speaking, unless you're actually doing something on the node itself, you should never really have to touch the nodes that are running on Kubernetes services. You can, they're exposed, and you can SSH into them, get a shell to them, and install stuff on them. But Microsoft makes no warranty of any changes that you make to the node. If you break something, it's your responsibility to fix it. So the best thing to do, what I found with Kubernetes, is just really don't touch the nodes. There's really no need to. And if you need that level of control over the environment, maybe AKS isn't the option for you. Maybe a maybe managing a cluster yourself would be what you would need to deploy then. I have, in my experience, never had a need to touch the nodes in Kubernetes services. So that's one of those things. I think Microsoft has done a good job of maintaining those. And for the most part, I just run everything through the AKS command line, and it works. It's easy to scale it. I can show you how to do that. It fully integrates with other Azure services like application gateways, load balancers, Azure file storage, Azure disk storage. You can integrate it with other storage options as well, because all those drivers are available in AKS. And it also supports most native functionality, and you can also bring in third-party functionality like Helm or other packages into Kubernetes to deploy things like Helm packages, or if you want to use Istio for monitoring, or Prometheus or something like that. All of these different tools aren't provided to you in Kubernetes services, but you can bring them to bear, and they will run on AKS just like they would on an unmanaged cluster as well. So this is the basic architecture of a Kubernetes pod, though, and this is the basic deployment unit on Kubernetes. And the reason why we need to talk about a pod is when I do a demo here in a minute, what I'm going to actually deploy to Kubernetes is not a container, it's a pod that contains containers. Now, a pod is similar to the container group that we saw earlier when we talked about container instances. Now, a container group is a set of containers. Now with a pod, you can have multiple containers running in that pod, and very similar to how the container group worked, where I can have a primary and a sidecar container. Same story here. I can have a primary container and a sidecar container that would do monitoring. However, in this instance with a pod on Kubernetes, I wouldn't put a database in the same pod as a web app, mostly because Kubernetes gives you the ability to put multiple pods on a Kubernetes cluster, and so I don't need that sidecar. I can just have a separate pod to run my database and another pod to run my web app, and then it can hit that database across the infrastructure that is provided by the Kubernetes cluster. So that is one of the advantages of Kubernetes over something like Azure Container Instances. So that having the ability to build complex applications would be one reason to go with Kubernetes over something like Azure Container Instances or app services. So The basic architecture of this is pretty simple. You have a name, you have some labels to do queries against you, and then you have storage that is provided to that pod. And it's either the host storage, which would be your host storage on the disk of the actual node that is running the pod, or that can be some kind of storage that is provided by something like Azure File Storage. And we're not going to get into the details of how to do all that. We actually have a current ongoing series on our YouTube channel where we're doing a deep dive into Kubernetes, and I'm going to be posting another video soon about storage, and we're going to be doing a lot of unpacking of Kubernetes as a service on Azure, as well as some of the other container options from that on our YouTube channel that will go along with this webinar. And then, of course, you have Kubernetes uses containers for deployments of apps running Docker containers. So with that, let's go ahead and talk about Azure Kubernetes Services and deploy and use a deployment of this. I've actually already deployed AKS already, and go back to my browser here. I'm going to select my resource group, Container Demos. Now, and this is my Kubernetes services that's running right here called Blaze AKS. If I wanted to deploy a new instance of this, I would come back over here and go create a resource, and then come down to containers and walk through a container services deployment. Now, this container deployment services gives me the ability to stand up a container services, a Kubernetes service instance running on a given region in Azure. Now, I can use a different version of this. They support from 1.13 up to 1.17 in preview at this point. The default is 1.14.8, which has a lot of bug fixes and stability issues, fixes some stability concerns with it as well. You can run 15 and 15.7 and 15.5, which are stable as well. I can give it a DNS prefix. This is where I can set up the primary node pool. I'm not going to get into the details of what a node pool is, but basically with a container cluster, you need nodes to deploy that to, and having node pools allows you to provide different applications, different node pools for running different workloads, and those can have different scales and different sizes associated with them. Now, with this, I can choose any size VM available to this. A B2 MS is a small VM. B2S is small would be fine for purposes that I'm doing in a demo today, which I'm not actually going to deploy this because it takes a minute to deploy. But then I would select the scale. With this, I would enable scale sets here if I wanted to do that. That's so that I can do auto scaling on my cluster against CPU nodes. And so by auto scaling my VM scale set that's running my nodes, I can actually automatically resize my Azure Kubernetes cluster here and have multiple node pools available as well. So, and when I'm deploying that, that's a good option to turn on, even if I never use it. It's good to have RBAC for security, and I can use the service principal to control this. Now, the service principal is used for automating the creation of things like load balancers and app gateways on Azure service, for automating storage and other things like that. It allows the AKS cluster to integrate with Azure, and this is for authentication and authorization against the cluster. So usually if you're running a large app or multi-tenant app, enabling RBAC is a good thing to have. HTTP routing, almost always want to turn that on. And with advanced network configuration, you can turn this on and bind it to an existing virtual network or new virtual network. If you're deploying this through an ARM template, I could bind it to an existing virtual network. But this will allow me to have a virtual network with things like virtual machines attached to it, or I can have something like endpoints for SQL databases on Azure connected to that virtual network that would allow the Kubernetes cluster to talk to that SQL endpoint over a private channel. So having this virtual network integration is a nice option for the purposes of making AKS a piece of a larger solution that would include other services on Azure. And monitoring, there's custom services for enabling monitoring on Azure. So basically there's a tool that's integrated with Azure Monitor that is designed for AKS as well as the containers on AKS. It's two different monitoring solutions. One is monitoring the container itself. One of them is going to monitor the cluster, and it'll give you things about nodes and things like that on Azure. And then tagging for organizing the resources. Once you have that all set up, you can do review and create. I didn't fill this out correctly, so it's giving me a failed validation. However, back in my resource group, if I go back to that, let's go back to my home here and go to my containers demo. I can show you what this looks like once it's deployed. There's my container instance here. Now I'm running version 14.8 here, 1.14.8. And if I go to my node pool, I have a single instance running on a B2S node here. So I'm running a single node Kubernetes cluster. For a demo, that's perfectly fine. If I was running this in production, I'd probably want at least 3 nodes. And the VM size is really going to be determined based on the size of the application that I'm going to be running here. And if I wanted to scale this up, I could come into my node count here and easily size this up to literally 100. If my actual subscription had that many GPU or CPUs enabled, I could scale this up to 100. That's why it's giving me this. I have a quota on my subscription, so it won't let me scale that high. But even so, if I didn't, I could definitely scale that up. And if I wanted to auto scale this, I could definitely auto scale it here. I'm not going to set that though for auto scaling because I don't need auto scaling here. If I wanted to upgrade my cluster, this is again where I was talking about that shared responsibility a moment ago. I can come in here and upgrade to a newer version of Kubernetes. Once I upgrade though, I can't go back. So keep that in mind if you are upgrading your Kubernetes cluster. And it will interrupt the workloads on there. So you have to take that into consideration whenever you're actually doing an upgrade on Kubernetes. Say, do that in downtime hours, or have a standby Kubernetes cluster that you're actually going to fail over to in case something doesn't work or something like that in the event that you upgrade your cluster. But other than that, the apps running on this will be, you can upgrade those using the standard techniques that you would otherwise use for running apps on Kubernetes. So this is actually really simple to use, though. Once it's deployed, I really don't have to configure a cluster, which is really one of the more complex things running Kubernetes, because Microsoft has done a lot of work to mitigate that by making it as a service. Your responsibility then is basically to run your apps on Kubernetes. It still requires that you have some knowledge of how to make Kubernetes work and how to make apps work on Kubernetes, but even so, by having it as a service, it mitigates a lot of that responsibility for having to figure out all the complexities of standing up and running a Kubernetes cluster even in a small environment is not a simple task. Now, to demo AKS, I have here a YAML file, and this is how I deploy things to Kubernetes. Now, there are UI tools for doing this. I'm not going to be using a UI tool for deploying this. I'm actually going to use a CLI tool. I'm going to use kubectl, which is the Kubernetes command line tool, to deploy this to Kubernetes. And this is going to deploy a simple app that's running through a so-called load balancer, but I'm only going to be running one replica of it, so it's a single container. But if I wanted to run 3 instances of my Commander Keen container here, I could easily do that with this deployment here. So this is going to do a deployment of a single container with this, and that's going to be basically a set of containers if I change this replicas from 3 to 3 like that, but I'm only going to use 1. And then this right here is going to expose that through a load balancer and give it a public IP address that is going to be provided by Azure. So just by running this simple config file here, what Kubernetes Services is going to do is going to create the pod for me with my container in it, and then it's going to provision a load balancer on Azure, and then it's going to create a public IP address on Azure for me, and then expose my Commander Keen container through that public IP address. So to do this, let's shut down my Commander Keen demo that I was running locally, and let's deploy my container here. Now, if I do dir, there's my YAML file that we just looked at. I'm going to run this. I'm going to run kubectl, and I'm going to do -f for the parameter, which basically means from file. Let's do create. I need to tell it to create, and then I'm going to do -f from file, and then keen.yaml. YML, and that will deploy this to Kubernetes. Now, if I do kubectl get pods, that's going to tell me what pods are running right here. So because I already deployed this once already to prepare for this webinar, it actually deployed this rather quickly. If in the first time I run this, though, it's not going to have that container image available on my Kubernetes cluster. So what it's got to do is go out there, reach out to to Docker Hub, pull that container back into the local context and start it. And because I ran this already, it had it already, and so it just started the local copy of the the container image in my Kubernetes environment here, and it's running. So if I wanted to get the deployments that I have, it's going to tell me the deployments that I have. So a deployment is made up of multiple pods. A pod is made up of one or more containers. And then if I wanted to get my services, which are the exposed load balancer for this, get services. In Kubernetes speak, a service is a load balancer, load balance application. There it is. It's a load balancer right here exposed at this external IP address. So this is the IP address I want to use in my browser. So I've exposed this on port 80, so I should be able to come to this IP address, HTTP:/, and then come into this, and there is that directory we saw earlier. And I'm going to come over here to my NoVNC client. I'm going to punch in that super secret password, pwd123, and there is my container. It's a fresh copy, so it's not already running. And then if I go cd keen, and I can run that same installer, install against my local box here. Now on a more high performance disk, I might get better performance out of this. It actually, in my experience, the one that ran this demo the best was actually AKS, because I think it's running probably a little bit closer to the metal through less abstraction, even though it is running on a virtual machine and through a Docker container, and that's because App Services has a lot of plumbing over the top of it, as well as Azure Container Instances as well. This one seems to be the smoothest of the three options that I had. So my performance here seems to be better, and I get less shearing, and it seems to be more responsive when I'm playing my game here on this particular deployment. So all in all, this is a fairly fun demo that I've used in other times I've talked about containers, because it has just kind of a fun appeal to it. But in any case, the Commander Keen container I've deployed to Azure Container Instances, Azure Container Web Apps for Containers, and now I've deployed it to Kubernetes, the exact same container in 3 different places. So it is really easy to deploy all 3 of these options on Azure. The question is, which one is the best? And most of that's going to come down to the nature of your application and the scale of your application. So now it's time for questions. We have a few minutes for this. If you want to, please do check out our website at winterlikenow.com or winterlikenow.com. Winterlikenow.com is our training site. Winterlike.com is our company's website, where we have information about the services we offer, including training and consulting. We have training related to Azure, we have training related to Kubernetes, and we have training related to containers. We have consulting services built around that as well. And you can also check out our YouTube channel, where we're doing an ongoing series at this moment, where we're talking about containers. Particularly, I just finished up a few videos talking about Azure Container Registry, and I've talked about Azure Container Instances already in depth, more than I've done in this webinar. And we're also going to be doing a webinar in March on Kubernetes services alone, where we go a little bit more in depth, as well as an ongoing series on our YouTube channel related to Kubernetes, and we're going to be doing deep dives into various aspects of it as well. So please do check us out online and follow us on Twitter if you want updates for when we post new content to our website, or upcoming trainings, or upcoming webinars, and so on in the future. So I'll pop open the question box and see what we have now. Third, and the question here is node versus containers. Node versus containers. I think we explained that a minute ago, but a node is a VM that is used for running containers. In Kubernetes speak, that is a virtual machine in a Kubernetes cluster that is actually used for running containers. So it's the one that actually runs your containers, while a container itself would be running on that node. So a node can run multiple containers. Really, a node runs pods, and pods run containers. But generally speaking, though, pods and containers are used almost interchangeably in the context of Kubernetes, because it's usually one pod to one container. Sometimes you have one pod running 2 or 3 containers if you have something like Istio that's doing for monitoring. Third question here is there any way to convert a Azure VM image to Docker image and host in a container? No, there's not because they're not compatible platforms. A VM image is a disk. It's an OS level image. It's not a OS level image. Is a operating system level image that allows you to have a operating system with all the apps and binaries contained within that VM image. Docker images are not the same thing. It just has the configuration for your application, and then Docker picks that up and then runs it. But if you can make generally speaking though, I will say this about this, if you can automate the deployment of your application to an image in Azure, such as a VM image, you can almost certainly do that to Docker as well. So what I found, that if I can automate a deployment of an application to an Azure VM through a script, say a bash script or something like that, I can take that same script into Docker and run it, and it will configure my application to run in Docker. So I don't have to configure a separate image and convert the image. I can just rather create a Docker image using the same deployment file or the same provisioning file, or maybe massage it slightly to get that same application to run on a Docker image or a Docker host or a Docker container as I would it into a VM itself. Does AKS support Windows containers? That's the last. Yes, it does. You can support, AKS does support Windows containers. I don't know that it's a deployable. I don't remember if it's, I know it's it was a preview feature, and I'm not 100% sure that it's a GA'd yet, but yes, AKS does support containers for Windows. In fact, I think the way that it'll support both in the same cluster, and the way it accomplishes that is you can have container node pools. One of those node pools be a Linux node pool, and the other pool be a Windows node pool. And the cluster would understand that you intend to run that in multiple. If you wanted to mix and match containers across the same cluster, the container cluster would be smart enough to put Windows containers on the node pool that is a Windows node pool, and Linux containers on the Linux node pool. So it allows you to have both running side by side. Now, it hasn't been perfect. I think there's been some hiccups with it. I think that's why it hasn't GA'd yet, but I think you can still run Windows containers right now. All the containers running in the same node share the same underlying OS. Yes, that is true. So if I have a Windows app, I can only use Windows containers and nodes. Is that right? Yes, that is the case, because containers are OS specific. So Windows containers have to run on a Windows guest operating system. Now, as I mentioned just a minute ago, with a AKS cluster, you can generally have node pools for Windows containers and node pools available for Linux containers, and you can have the same cluster have both of them available. However, the basic rule of thumb here is, you have to have Windows containers running on Windows host and Linux containers running on Linux host. Is Kubernetes replacing Service Fabric? The answer to that is no. Service Fabric is a special platform. It can run containers, and Service Fabric as a platform is generally designed for microservices. So as a platform, Service Fabric is designed for specific use cases that are used for supporting applications that run microservices. And one thing you can do with containers is run microservices. So the support that Service Fabric offers for containers is generally intended to run microservices within a container. That having said that, doesn't mean that you can only use Service Fabric for microservices. Microsoft tends to sell it as a general purpose orchestration platform. As a rule, though, if you're going to use Service Fabric, it's because you're already using it and you want to use it with containers. That's why you would want to use it. I would, as a rule, prefer Kubernetes over Service Fabric as a general purpose tool. And if I needed Service Fabric specifically for use cases surrounding Service Fabric, then I would use it then. But as a rule, no, it's not exactly apples to apples comparison. So to say it's replacing Service Fabric would be, no, it's not. To say that it's a competitor Service Fabric would even be somewhat of an overstatement, because they're really, think of Service Fabric as a purpose-built tool and Kubernetes as a Swiss Army knife that does a lot of things. And you kind of have to build Kubernetes out to be what you want it to be, while Service Fabric has a specific design patterns in mind whenever you're going to deploy it. So if there's no more questions, that was the last question on my list. So if there's no more questions, will thank you for attending this webinar. I look forward to seeing you on future webinars related to we will be offering Azure-related technologies. We have a upcoming webinar that is going to be related to data and AI that will be offered in, I think, 2 weeks. And then there will be a follow-up webinar in March where we're going to do a deeper dive into Azure Kubernetes Services, and also be posting all this content on our YouTube channel as well. So you can check it out there, and you can see everything that we have going on. So if there's no further questions, I thank you for attending, and I hope to see you on future Wintellect webinars.